Hello, and in this video we're going to look at how to work with time and dates in C++. Unfortunately, C++ doesn't really give us much, just some types and functions which were inherited from C and were done pretty early in the C language. These functions are low level, not very well defined. We can access them by including the CTime standard compatibility header. In 2011, C++ added something called chrono to the standard library. This can be used to measure intervals with very high precision, usually down to a nanosecond or so. Unfortunately, the syntax for this is rather complicated, so we're not going to be looking at it in this course. The good news is that the next version of C++, C++20, is going to have proper data handling with classes and other modern conveniences. Okay, so we're going to look at what we do have. We'll start off by finding out how to measure intervals. This means calculating the time between two events. There's a function called clock which returns a number of so-called clock ticks since the program started. These are stored in a variable of type clock_t, so that's what the clock function returns, a value of this type. This has quite a small range of values, so we can only use this for calculating intervals of up to a few minutes. The precision is usually 1 microsecond, so that means we can measure intervals down to the nearest microsecond or so. You might think that these clock ticks have some correspondence to the CPU speed. In fact, it's a completely hypothetical number. Usually we're not very interested in clocks, especially if they don't correspond to reality. We're interested in seconds and fractions of a second, and we can get that by dividing the clock ticks by clocks per second. This is a constant which is defined in the CTime header file. This is an integer type and clock t is an integer type, so we need to be careful when we're dividing them, because by default they're going to do integer division, which will ignore any remainder. So if we divide a clock t by clocks per second, that'll give us the interval rounded down to the nearest second. If we want to have the decimal points, we need to use floating point division, so we need to cast clocks per second to a floating point type. Okay, so this is a typical example of how to use clock. We're going to find out how long it takes for a function call to run. We call the clock before we call the function, then we call it again after the function has returned. We subtract these two values, and that'll give us the number of clock ticks that occurred while this function was running. Then we divide that by clocks per second to get the number of seconds that it took for the computer to call this function. So the code will look like this. We call the clock, we save the value returned, we call the function we want to measure, then we call clock again just after it returns and we save the return value from that as well. We subtract the two, that gives the number of clock ticks that occurred while the function was being called. Then we divide by clocks per second, we cast it to double to make sure that we do floating point precision, so we get all the decimal points. Then we can display the result. One important thing to bear in mind is that computers are multitasking. The CPU is not just sitting around waiting for this program to order it to do something. There'll be other programs running which want the CPU's attention and also operating system tasks. So when this function is called, it'll be executing the instructions in here, but it'll also be executing instructions from other programs and the operating system. So this time here is probably going to be quite a bit longer than it would for just to execute the function on its own. You may also get different results. So for example, if the CPU is really busy and lots of other things are going on, this function may take quite a long time to call. If there's nothing else happening really, then this function will get a lot of CPU time and it'll execute much more quickly. So you can find that you do this several times and get several different results. This is known in the jargon as the wall time, because in the old days they used to look at a physical clock on the wall of the room as opposed to calling the clock function, but it's basically the same concept. You're measuring the total time which the computer needs to execute this function, as opposed to the total time which the computer actually spends on executing the instructions in that function. So that's how we measure short intervals. What happens if we want to measure a long interval? In that case, we can call a function called time. This takes an argument which is a variable of type time_t, and it takes it by address. It'll set this argument to the number of seconds since the 1st of January 1970. I'm not sure what exactly happened on New Year's Day 1970, but it was obviously very memorable for the person who wrote this function. Time t can take a much wider range of values, so we can use it for much longer intervals. In fact, we can go up to, I think it's 68 years is the maximum. It measures things in seconds, so obviously the precision can't be any more than 1 second. So our results will be to the nearest second. If we want to calculate the difference between two time t values, we call a function called difftime instead of subtracting them. So this is how to do the same example, but using time. We start off, we need to have two variables, one for the start and one for the finish, of type time t. We call the time with the first one as the argument. Then we call the function. Then we call time with the second time t variable as the argument. So this will set the number of seconds at the start of the function call, and this will have the number of seconds at the end of the function call. Then we call difftime to subtract them, and that will give us the number of seconds that elapsed while the function was being called. Again, that's the wall time and not necessarily the actual CPU time executing the instructions in that function. Okay, so that's how to measure intervals. Now let's move on to looking at dates and time of day. There's a data structure called TM, which is a C++ struct, so that's a compound data structure with members, and this can store information about dates and times. There is actually a function, or two functions in fact, which are provided for initializing a TM struct given a time t value. If we call the localtime function, that will populate the TM with data corresponding to the time zone that the computer that the program is running on is set to. If we call GM time, that will use data for universal coordinated time. Originally this was Greenwich Mean Time, which is why the function is called GM time. Then they discovered things called leap seconds. This is basically because the number of seconds in a year is not an exact number, and after a few years the calendar is either a second fast or a second slow, so they use leap seconds to make up the difference. It's a bit like leap days. So universal coordinated time is Greenwich Mean Time, allowing for leap seconds. Okay, so an example of using this. So we have a time t variable. We call time to get the number of seconds since 1970 into this time variable. Then we call local time. We pass it this argument. Again, we have to pass it by address, even though we're not changing it. And this will return a pointer to a struct tm. Again, you can see this is rather a strange interface. So these are the different fields that are stored in a struct tm. We have seconds, minutes, hours, the day and the month. So the 4th of February would be 4. We have the month as a number from 0 to 11, so February will be 1. We have year, which has the years since 1900, not the actual year, but the number of years since 1900. We have W day, which is the day it's in the week. So 0 is either Sunday or Monday. Y day is the day of the year, so the 1st of January is 0. There's also a flag which can be used to find out whether daylight savings time is in operation. Daylight savings means that an extra hour, or possibly some other more than 1 hour, is added in the summer, so that we all have to get up an hour earlier and go to bed an hour later, or I think that's how the politicians want us to believe it anyway. You can see here that the formats are quite strange. Second goes from 0 to 61, so 0 to 59 is a normal minute. 60 and 61 are for leap seconds. Minutes and hours are 0 based. Day in the month starts with 1, not 0. Years since 1900, so 2019 is going to be 119. Right, displaying dates and times. So we've got our date and time information in a struct tm. There are two different functions again that we can use for displaying the date. One of them is ASC time. I think that's just short for ASCII. I'm not sure why ASCII is significant here, but there you are. It'll display the time in a fixed format. So we give it the struct tm and it'll return the date in a fixed format. So the date when I wrote this slide was Monday, Feb 04/12/1905, the year 2019. That's okay if you just want to do things like write data to a log file. If you want to be able to choose your own format, there's a function called strftime, and this works a bit like printf. So we have a format string, then we have the variable that's being formatted. The characters are different from printf. You can look them all up if you want to know. I've just used %Y here, which is the year with 4 digits. %m is the month, 2 digits. And %d is day, again with 2 digits. We also need to give it an array, a buffer, so we can do that by declaring this array of car here. We also need to tell it how many characters are in the buffer. I've made 100 characters just to be on the safe side. And then we can print out this buffer. So this function will take the struct tm, it'll take the data about the time and date, it'll format it according to the string and stick it in this character buffer. Then we can print out the buffer. There's rather a nasty feature to this. You remember that localtime returns a pointer to a struct tm and not just a struct tm. And they had the bright idea of returning a pointer to a global variable. So every time we call localtime or gm time, this global variable has the latest value stored in it, which will destroy whatever was in it before. So if we do something like this again, we get the time and we call localtime to get a tm struct. Then we call localtime again to get the tm struct for after the function is completed. Then this is actually going to be written into the same address as that one. So this is going to overwrite the data that was in there. So begin and end are now going to contain the same data. So if we try to use these variables, they'll both contain exactly the same data. And if we call ask time, they're going to print out exactly the same time and dates. I think I've fallen into that trap a couple of times, so it is something to watch out if you have to use this. Okay, so as you can see, there are quite a few problems with this design. The first one is that it's verbose. If you just want to display the time and date, you have to call 3 functions. You have to get the time, then you have to call local time or gm time, and then you have to call ask time or strf time. The data formats are inconsistent. The month and the year use completely different conventions from all the other fields in the struct tm. There's no encapsulation or validation of data. So if someone comes along and changes the values in a struct tm, so if you call local time and then someone accidentally or deliberately changes the year in your struct tm, the language will quite happily allow them to do that. There's no validation of data either, so if you accidentally put -99 as the year, it'll just accept that as well. It might crash when you try and do something with it, but it will actually take it. Finally, the problem we mentioned before, local time returns a pointer to a global variable which gets overwritten every time it's called. So this is a bit of a pain, but it's also a good example of the problems that arose with procedural programming and why people felt the need to go to object-oriented programming, particularly for encapsulation and validation, and also for avoiding problems with global variables. Okay, so let's sum up this video. So to measure short intervals, we use clock. We subtract the results and divide by clocks per second. To measure long intervals, we use time and diff time. We use time and local time to get the date, and we can use either AskTime or strftime to display the date. Okay, so that's it for this video, and that'll probably be it for this course. I hope you'll consider joining up for my advanced C++ course, which I'm currently working on. Until then, whatever you do, good luck and keep coding.